In this video, I will walk you through the solution to the race practice problem for my AP Physics class. So the problem goes like this. In a 100-meter race, Bill and Ted cross the finish line at the same moment. Both of them take 11 seconds. Accelerating uniformly, Bill takes 2 seconds and Ted takes 4 seconds to attain their maximum speeds, which they maintain for the rest of the race. So here is how it goes. I'm going to make a plot for each of these people. So here is time on this axis in seconds, and let's do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 seconds. And we'll put velocity on this axis, and we'll start out with Bill, who takes 2 seconds to get to his maximum speed. I'll put Bill in orange. So in 2 seconds, he will get to his maximum speed. So we'll go like this. And then, okay, so the orange plot represents the speed of Bill. And we want to find out what the maximum velocity that Bill has while he is running. We know that he travels a distance of 100 meters in these 11 seconds. So let's use this. The distance that Bill travels is going to be the area under this graph right there. So the area of this rectangle plus the area of the triangle. So the area of the triangle, that's the distance that he travels while he's accelerating. It's 1/2 of the base of the triangle, which is 2 seconds, times the height of the triangle, which would be whatever Bill's velocity is. So that'd be the area under that section, plus whatever distance he travels while he's going at a constant speed, and that would be the area of that rectangle, which would be 11 minus 2, that would be 9 seconds, times whatever his velocity is. And that whole thing, the sum of those has to be 100 meters. So you can see here, this whole term becomes just VB, and this term right here is 9 VB. I've dropped the units to make it a little bit simpler to write, and that has to equal 100, or in other words, 10 times Bill's velocity is 100, so Bill's velocity is 100 over 10, or 10 meters per second. So we just found out that Bill's maximum velocity is 10 meters per second, so that he travels 100 meters in those 11 seconds. Okay, what about for Ted? Well, Ted also goes 100 meters in 11 seconds, but apparently he takes 4 seconds to get to his maximum speed. So I'm going to guess that his maximum speed is going to be a little bit larger than Bill's, so that when he's accelerating like this, and then he's going at this maximum speed like that, the idea, I know that's probably not exactly to scale, but the idea is that they need to go the exact same distance in the same amount of time. So since he takes longer to get to his final velocity, he's going to actually have to be going a bit faster. So the distance that Ted travels is going to be, well, the area under this triangle right here, which is 1/2 of the base, which would be 4 seconds, times whatever the velocity that Ted is going at. So that'll be up here. That is going to correspond to the velocity of Ted. And you add on, well, 11 minus 4 for 7 seconds, he is going to be going at whatever his velocity is, and that has to equal 100 meters. So I'm going to simplify this. 2 VT plus 7 VT equals 100, or 9 VT is 100, or VT is 100 divided by 9, which is what, like about 11 and 1/9, 11 and 1/9, right? 11 and 1/9 meters per second. So he is going a little bit faster. Okay, so we have the two velocities, the velocity of Ted, the final velocity that he reaches, 11 and 1/9 meters per second, and Bill is going at 10 meters per second. Okay, we're asked what is the acceleration of each of the sprinters. So the acceleration of Bill is going to be whatever change in velocity he had, which was 10 meters per second, and it took him 2 seconds, so it would be 5 meters per second squared with the acceleration of Bill, and the acceleration of Ted is going to be, he gets up to 11 and 1/9 meters per second, and that was in 4 seconds. So whatever that is, I'm not going to simplify it. So 11 1/9, well, I'll just do 100 over 9 would be 36. So 100 over 36 would be like, what, 50 over 18? 25 over 9. 25 ninths meters per second squared would be the acceleration of TED. All right, and then finally we're asked what is the, which sprinter is ahead at the 6-second mark. Okay, well, we're gonna have to figure out the area encompassed by each of these at the moment one is at 6 seconds. So the distance that Bill travels during the first 6 seconds is going to be, well, the area of that triangle, 1/2 times 2 seconds times the velocity of Bill, which was 10 meters per second. And then add on from 6 to 2 would be 4 seconds times 10 meters per second. So he will have traveled 10 plus 40 is 50 meters during the first 6 seconds. So during 6 seconds, Bill travels that far. How far does Ted travel? Well, Ted travels the 1/2 times 4 times, well, 11 times 100 over 9. That's the speed. And we have to add on between 6 and 4, which is 2 seconds times 100 over 9. And to simplify this, we'll have 200 over 9 plus 200 over 9 would be, what, 400 over 9, which is going to be how far? Well, let me quick plug this in to a calculator. And that is 44 4/9 meters. So the answer is that Bill is ahead at 6 seconds.